How's it going, everyone? I'm Joneal, and I will be talking to you about chapter 29, which is about how usable are your APIs. Some questions to ponder throughout this chapter are: how do we improve a developer's overall user experience? How do we measure an API? Often do you create a new project compared to everything else that you do? Also, why study API usability? Um, First off, how do we improve the developer's overall user experience? Does it mean we need better development tools like improving the IDEs that we use? Do we need to add more buttons to those IDEs? Do we provide it with more functionality? Ironically, although the developer's experience with development tools increase, the overall experience does not. That means we need to change the focus of improving the user experience. Rather than improving the development tools they use, we need to measure and improve the class libraries and the APIs that the developers use. In an ideal world, the tools really just let the developer type in their code and run their programs. So how do you measure an API? Measuring an API is not like measuring an object with a ruler. There really isn't a unit of measure. You can't give it a number, but however, it varies from one individual to another. So why is it important to study API usability? We have to look at the purposes of an API. APIs are supposed to increase a developer's productivity by providing components that perform common tasks. As well as APIs, they save the developers the time and effort required to create their own implementations of those components rather than create them from scratch. Well, however, unfortunately, when an API is badly designed, it can be difficult to determine whether the time saved using the API is worth the investment of effort in using it. A guy by the name of Alan Blackwell, he developed a model for describing how to determine whether such an investment of using a custom programming solution is better than using a predefined API. So the developer estimates the cognitive cost of using the API as well as the cost of figuring out how to use the API, then weighs these costs against the payoff, the potential savings in time and effort that they will accrue by using the API. To conduct the study, the developer uses cues in the API design such as class names, method names, and documentation to estimate the cost involved. Particular design patterns employed in the API might be recognized by the developer and might help to better understand how to use the API. But common misconceptions is that class names and documentation, for example, they can have inaccurate meanings and they can be very misleading. Also, the names, they have multiple meanings. Also, prior experience in different parts of the API might not indicate how other parts of the API actually work. So Stephen Clark, the actual author of this chapter, conducted a more extensive study. He helped create Microsoft Visual Studio, or one of the he was on the team that designed the APIs for, and basically Stephen Clark, how his first study came about, he blamed himself, or he compared himself to typical programmers and blaming himself for not understanding how to use an API rather than blaming it on poor design. So he conducted a study on programmers who were creating the API called ATL Server. They worked on the Microsoft Foundation classes previously, but had no prior experience with web applications. He wanted to test, in the study, he wanted to test if the architecture of an API is a problem. That was due to this team that he was working with. They gave him a task of finding the best way to design an API. So he decided to use the card sort. With each card in the card sort, there would be a concept or object name, and that would be used in the ATL server API. But in conclusion, there were no common groupings. So he concluded that API usability isn't a function of the whole API. So that led him to believe that he needs to study the API when it's actually in use. So in his second study, he used programmers who had previous experience with Visual Basic 6. They were to use these programmers who had this previous experience. They were to use Visual Basic.net, which had similar functionality to Visual Basic 6, but had different classes and namespaces. They were to perform common tasks such as reading and writing from text files. And they were given 2 hours to finish that task, and as well as think out loud while being videotaped. And ironically, the one finished in the allotted time, prompting him to blame documentation, which also happened to be a less costly fix in the project lifecycle at the time. And that led him to want to use cognitive dimensions framework just to make sure. It's used to measure attributes of each dimension in the API and also provide a vocabulary to discuss each attribute. And there are 13 dimensions, and they are abstraction level, learning style, working framework, work step unit, progressive evaluation, premature commitment, penetrability, API elaboration, API viscosity, consistency, role expressiveness, and domain correspondence. Sorry about that. And based on this study, one of the problems they found with the previous group was that abstraction level was a problem. Although documentation seemed concrete, the mapping of the classes did not map out the way developers expected. For example, in this transcript, one of the developers made a statement saying one of the classes is too low level. When he meant too low level, he was referring to the abstraction level. Overall, it was a good study for Stephen Clark. He had good results. However, his previous study was based on opportunistic developers. Based on other personas from previous studies, there are also pragmatic and systematic developers. And adapting to different work styles fell to him trying to work with scenario-based design. So when we talk about APIs, we commonly talk about them as a complete set of classes. From his previous studies, he learned that the API team thinks of the complete set of classes as opposed to how developers think of the API, and they only think of the classes that they will use. So when it comes down to the example of the ATL server, pragmatic developers rather only work with binary data, and systematic developers would prefer to work with the flexibility that abstraction offers. And to conclude, one thing I found ironic at the end of this chapter was that he never really gave a measurement of how usable are the APIs, and that was the topic of this entire chapter and the main question. But however, he gave insight on what is to come on APIs. Basically, APIs are very complex, and studying them is just the beginning. As time advances, there are certain trends in development, and that it dictates the usability of APIs. And my comment on this was I'm like Stephen Clark, and I don't really have a definite measure of how useful an API is, because what I might find useful may not be useful for other people. And this chapter actually had a lot to do with my project, with me and my partner because we wrote in Java and we use the Java API. It's a very big and extensive API, and we only use some of it. And picking classes that we needed as well as how to use them was a challenge. So as far as the studies he conducted and the people that he did the studies on, I can relate to all of them. And this concludes my project.